Welcome back to AP Pre-Calculus. This is lesson 2.2, change in linear and exponential functions. All right, in the other day's lesson, we learned that arithmetic sequences behave like linear functions and geometric sequences behave like exponential functions. Okay, so this page is just an overview of the formulas that we'll be working with. This is your basic, this is the one that we'll use most of the time. This right here, if you simplify it and get rid of the parentheses, turns into this. Okay, so, but we usually work with it in this form. And then down here is our geometric, and this is the one we normally use. Remember, ratio is like our base of an exponential function. Like base means it has an exponent. So we have a lot of bases, but the base that we're worried about is the number that has the x as an exponent, okay? Or an n, or a variable. As long as there's a variable in the exponent, that would be your base. All right, so look at this chart. We really need to get this chart and understand what it's talking about. So on one side, we have linear functions. The other side, we have exponential functions. We have the equations for them here. Looks like a line, mx plus b. Looks like one of our growth or decay models from last year because we have a base, all right? This next box is the important part. I want you to notice that both of them start the same way. Over equal length input values. It doesn't have to be 1, doesn't have to be 2, but it has to be the same. So if I'm going from 1 to 4, the next one has to be 7, the next one has to be 10. So if I'm jumping equal lengths on my x values, the output values have a constant rate of change. So they're going to be adding the same number over and over time. Whether that's a positive number or negative number, who cares? They're just adding that same number over and over again. Over here in exponential, it says that they change proportionately. That's just a fancy way of saying that we are multiplying by the same number over and over again, okay? So proportional means it's a fraction. So to get to the next one, you had to multiply by some fraction. The fraction doesn't have to be like a fraction that you see. It could be 3 because that's 3 over 1. All right. So back to linear. The change in m is based on addition, and the change in b is based on multiplication. All right. So your y values, those changes are based addition for linear, based on multiplication for exponential. If we have 2 points, you can write the equation of a linear function, an exponential function, the arithmetic sequence, or a geometric sequence, okay? All right, so this is the kind of thing you might see on the AP test. They'll give you a chart and you have to figure out what it is. So what we want to do is start out looking at the input values. So these guys right here, right? They have to be the same. That's 3, 3, 3, 3. Okay, good. So now we have a chance of being one of the other things. This one is subtracting 2. 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 Hey, look at that. It is a constant rate of change. It stayed the same the whole way through. This is linear. All right, let's look at B. My input, I'm adding 1 every time, right? So this has a chance of being one of those. So let's see what we got here. All right, we added 1, we added 3, we added 5, we added 7. Well, that's not adding the same, so it's definitely not linear. And I'm not multiplying. If I have a 0 and I can multiply by anything, the next number has to be 0. So this one is neither, right? It's not linear or exponential. By the way, if we did the difference again, if we did this, we'd get all 2s. When our second difference is the same, that means it's a quadratic, if you remember that from last year. All right, let's move on to C. 0, 2, 4, 6, 8. So x's are good. Let's see. That's 1. That's 2. That's 4. That's 8. Well, it's definitely not linear, but notice I'm multiplying by the same thing, right? So this one is exponential. Okay, on my last one, 5, 10, 15, 20. X's have equal jumps. Let's look here. I'm subtracting 40, subtracting 20, subtracting 10, subtracting 5. Okay, it's definitely not linear. Let's look at what we got here. If I multiply, what can I multiply 80 by to get to 40? Well, I could multiply that by 1/2, right? What about 40 to 20? 1/2. 20 to 10? 1/2. 1/2. I multiply by the same thing over and over again. This is another exponential. Just it's a decay model this time instead of a growth model like the last one. All right, example 2, a word problem. We love word problems. A wild rumor is spreading that Mr. Passwater won 3rd place in the world's strongest man contest. Mr. Passwater probably didn't start the rumor. The number of people that have heard the rumor can be modeled by using a geometric sequence. So I know that I have this, right? G of n equals G of k times r to the n minus k. So if I can figure out some of these numbers, we're going to be good. All right, it says 43 people heard it on day 3. So G3 equals 43. And then 140 people heard it on day 6. So G6 equals 140. So I can fill in some of these numbers because I need to figure out the R, right? That the R is what's getting me. So I'm going to go ahead and... So which of those numbers comes after in the list? Now, don't look at the value. I don't care about the value. What comes second, G3 or G6? So G6 comes second, so 140 equals 43. Rate. This guy over here was my n, so I'm going to put a 6 up here, minus 3, because the k was the 3. All right, and then do a little bit of math. 140, 43, r to the 3rd. All right, so that makes my r this beautiful number of 140 over 43 to the 1/3 power. That's gross. Don't figure out what that decimal is. Just leave it here because this is actually better because this is exact. So let's write it down. We got G to N equals, pick one of these numbers. I'm going to use 43. Could have used 140. It doesn't matter. Do 140 over 43 to the 1/3. And then we have N minus K. I use 43 for my G sub K, so that's minus 3. So that looks disgusting, but it's okay. It's okay. We have calculators that will do all of this awesomeness for us, okay? So we want to find G sub 10, right? By the way, please do not cross out the 43 on the outside with the 43 on the inside. I have a rule that you have to follow. If you see an exponent, do not multiply bases, okay? 43 is a base. It's 43 to the 1st power. It has an exponent. And obviously, the parentheses has an exponent. It's got a lot of them. So don't multiply bases if you see exponents. So we're going to leave the 43 right there. We're going to leave the 140 over 43. And I'm going to go ahead and put 1/3. I'm going to do this in my head because I'm going to put a 10 up there where the n goes. Hopefully you can do 10 minus 3 in your head and do that. And just when you put it into your calculator, make sure that you put it in that whole numerator in parentheses. Or you could do a little bit more math in your head and do 43 times 140 over 43 raised to the 7/3, right? And I definitely need my calculator for this, so let me grab it real quick. So hopefully we got 675.5759. However, you got to be able to read. Up here it said to the nearest whole number. So do we round up or down? This will round up. So we got 676 people. Boom. All right, last example. A large theater has rows of seats where the number of seats in each row can be modeled by arithmetic. Oh, let's write that down. A sub n equals A sub k plus d to the n minus k. All right? All right. The 5th row, so A sub 5, has 31 seats. And then the 11th row, A sub 11, has 49 seats. Remember the nice easy way to do this? Change in input, change in output, and then we can just do output divided by input, and we get a D equals 3. All right, so let's write our formula. So A sub n, pick one of those numbers. I'm going to be different this time. I'm going to use the 49, so A sub 11. I know my difference is 3. I don't know n, but I used A sub k. I used A sub 11, so I'm going to put minus 11 right there. Okay? So it wants to know how many are in the 25th row. So A sub 25 equals 49 plus 3 times 25 minus 11. And I really don't feel like doing any mental math right now, so I'm just going to grab my calculator. And I get 91 seats in the theater. Boom.